Alright, first and foremost, can you take a guess what this represents? You can see there that is a diagram with the body parts of a penguin, and it is free. So obviously you can say this is a free body diagram, right? Alright, so Bismillah, Assalamualaikum warahmatullahi wabarakatuh. For today, we will cover chapter 5, which is equilibrium of rigid bodies, but we will focus only on the free body diagram part, and the calculation part we will be covering that on the later or the next tutorial, inshallah, right? So hopefully you have covered the lecture and you have understood what is the free body diagram, right? So before that, as usual, do test your mind whether you understand what to do and what not to do. And if you need the PDF for the questions that I've taken from the previous exams on specifically on this chapter, on this topic, you can download the PDF in the description box below, inshallah. Before we go to the question, just to refresh, what is a free body diagram? So number one, it should be a diagram, right? So it should be understood as a diagram. Second, the body must be clear, right? So what or which object are you considering as your body that you are drawing in the free body diagram, right? So if it's not clear, this is for which body, what is the body here, then it's not a free body diagram, right? And third, it should be free, right? So meaning that any surrounding, any support, anything that is outside of the body should not be in the diagram, right? It should be the body and whatever forces, reaction forces that represent the surrounding objects that interact with the body, right? So hopefully the concept it is clear, and hopefully you have understood what we have covered in the lecture, right? So now, as usual, we will focus on the previous questions or the questions from the previous exams, and we'll just focus on the free body diagram part, inshallah. Alright, so we will go straight to the question number 1. Okay, in this question, you can see the diagram there, something like a beam, and then we have the support at A and B, and then we have the distributed loading between A and B there as shown, right? And the question says, determine the reaction at the supports A and B for equilibrium of the beam shown in the figure. So if you have this kind of question, the first thing that you have to be able to do is to draw the free body diagram and then solve the equilibrium problem, right? You have the summation of forces equal to 0, summation of moment equal to 0, right? But in this tutorial specifically, we focus only on the free body diagram, right? If you look at the diagram, to be able to draw the free body diagram, you have to incorporate what you have learned before, right? So here you have distributed loading. Hence, I would assume you already know how to deal with distributed loading. Otherwise, please check out the lecture and as well as the tutorial on that part, right? So basically you have the beam, right? And as we have mentioned, the beam should be free from the surrounding, meaning do not draw the pin, support, the roller there, or anything else, right? So it should be free, right? So we only have the beam, and then you have to draw the forces acting on the beam, right? So we focus on the distributed loading first, right? So basically, if I'm to resolving the distributed loading up here, so something like this, right? So this is what we have done in the previous tutorial, right? So we have one force here and one force here, right? So in terms of the distance, right? So this one it will be at the middle, because this is the whole thing is 7, so you have 3.5 meter here, where this is the, is it the middle? Roughly the middle, right there, right? 3.5 meter there. And then we have another force here where this one is 3, so 1 meter here, right? Or yeah, or if you want to take the distance from here, it would be 6 meter, right? So that's the location. What about the force itself? So we have here 100 Newton per meter, that height, and this height is another 100 Newton per meter. So of course this is 3, this whole thing is 7, right? So this one becomes 100 Newton per meter times 7 meter. You will get 700 Newton over there. Hopefully my writing is not too small. Hopefully you can see. Alright, so that is 700 Newton. This one will be, the value here will be half times 100 Newton over meter, and then 3. So 300 over 2, which is 150 Newton. Right, so that's the two force coming from the distributed loading. Right, so in terms of the free body diagram, so I assume you understand already how to deal with the distributed loading. We have covered before, so I'll erase this one. This is, so right, so that's the force from the distributed loading. What about the force from the support reaction? Right, so I'm using a different color here. So if you see at A, you have pin support, right? So hopefully you understand the concept. If it prevent movement or movement in horizontal axis, then you have that horizontal reaction force. If it prevent any movement in vertical axis, it does have reaction force in the vertical axis, right? If it prevent rotation, then you have moment reaction, right? So for point A, this is point A, right? So okay, so that is point A. Because it prevent X movement, it prevent Y movement, but it does not prevent rotation, right? So basically you will have AX and as well as AY, right? So you have reaction of AX and AY. Now the direction is assumption, right? So it can be to the right or it can be to the left. You have to assume one. It can be upwards or downward. You have to assume either one, and then in the end when you calculate, you will know whether your assumption is correct or not based on whether it's positive or negative, right? Now in terms of the roller, it only prevent from going down, right? It doesn't prevent any horizontal or rotation. So you will have, this is point B, right? So you have normal force at B, right? So basically this will be the free body diagram, and you will have three unknown, 1, 2, 3 unknown, right? So and we will discuss in the next tutorial in terms of the number of unknown, etc., because that is already related to the number of equations, etc. But in terms of the free body diagram, from the original diagram here, I hope there's no problem for you to get into this diagram here, right? So this is basically the complete free body diagram have to have all the items. One is the outline of the body, the beam. Second, all the forces, and all the known forces need to be numbered. All the unknown forces need to be labeled properly. So this is known and known. You have to have the number. You cannot have ambiguous something there. You have to have the exact number. All the unknown have to be labeled properly. A, AX, AY, and NB. And all the dimensions have to be there, all these distances, right? Why? Because in the next step, you will have to do the calculation, and all the information in the calculation should come from the free body diagram. It shouldn't be miraculously, magically appear, right? So when you want to calculate moment, you will have to have all this distance, right? So obviously this distance must be in the free body diagram. All right, so that is it for this question number 1. Until the free body diagram, that's it, right? Obviously this is not the final answer in the final exam, because this is only the first step before you calculate onwards, right? So but it is very, very important to get it right, because when your calculation is depending on this, any mistake will affect the whole calculation, right? So make sure you understand really what type of reaction is there, etc. All right, moving on to question number 2. Okay, this is question number 2 for this tutorial session, but if you observe and you notice, the diagram is very similar to previous question, right? It's just, the difference is just the number, the value of the force, and also the dimension. So from here you can see that actually some questions are being recycled from exam to exam. But regardless, we will see just the question, right? So you can see the diagram, and then the question is, Determine the reaction at the supports A and B for equilibrium of the beam. And part B, if the support at B is replaced by a pin support, can the reaction at support A and B be determined, and why? Right, so this is another type of question. Okay, so it is basically the same or similar question. The diagram is just rearranged, right, basically from the previous question that we have discussed. So this should be straightforward in terms of drawing the free body diagram. I just want to highlight at the question number B, you have to understand also what is the implication of certain type of reactions, right, because there are some questions like that. All right, moving on to the free body diagram first, right. So basically from here, it's just going to be, again, the outline of the beam, right, and then you will have the forces from the distributed loading. So you'll have one force here and one force here. You have to get the value, of course. Okay, how to get the value? Okay, so if just looking at that, so this one, the value will be 200 Newton over meter times 8, right? So 1600 Newton, right? And this one is 1 over 2 times 200 times 3, right? So 300 Newton, right? So that is the forces, the point force from the distributed loading. So in terms of the distance, this one will be 4 meter. That one wanted, so this one will be 7 meter, because this is basically 1 meter, right? The whole thing is 8 meter. Okay, so, and I have mentioned in some of the tutorial before why I have the tendency to always show the distance from one side, because when you take moment afterwards, when you calculate, you tend to you have to take moment about a certain point, right? So it's easier to avoid mistake from my perspective if you have all of distance like this, so that you just have to multiply by the distance, right? If you have force distance here, sometimes if you forget to add, etc., that's a very bad way to lose marks, right? So basically that's just a suggestion. Of course, for the support reaction, we have understand already pin support you'll have. Okay, just to have a different example, right? Because before we show assuming to the right, so if I assume to the left, for example AX, and if I assume upwards, this is similar. So this is also acceptable in the sense of it does represent pin support, right? You have horizontal and vertical reaction, and here you'll have and B, right? So now, even though this can be to the right or to the left, this can be upwards or downward, this one I hope you understand already from the lecture that why it should always be upwards, and if you draw downwards straight away, that is wrong. Fundamentally that is wrong. It means that you do not understand what you are doing, right? So make sure you understand why this must be only upwards. This can be right or left, this can be up or down, right? So that will be the free body diagram for this question. It's very similar to the previous question, so I think we'll just go to the next question. Now take a look at this question. On the left here you have the diagram, and it's a certain shape there is the dimension given, and then you have the equation there. And the question says, part A, the steel plate in figure 4, in the figure there, is 0.4 meter thick and has a density of 7800 kilogram per meter cube. Determine the coordinate of the location of its center of mass. Clearly state which element is being used if integration is used for calculation. Part B, draw the free body diagram of the steel plate. Part C, compute the reaction at support A and B. Alright, so if you look at this question, before you can even draw the free body diagram and then calculate, which is part B and C, there's something coming before that you have to determine first. Otherwise you cannot draw the complete free body diagram, right? So this question actually fundamentally, in terms of drawing the free body diagram as well as finding the support reaction, it is from chapter 5. However, to be able to start, you have to settle using chapter 9 first, right? Which is quite interesting because some question is as such where even if I understand completely chapter 5, but if I cannot solve chapter 9 for this particular question, the same question, you cannot move on, meaning that you will be stuck because your free body diagram is incomplete. You don't have all the parameters to draw the free body diagram and to use to calculate, right? So that's how interesting some question can be, right? So obviously for part A, we cannot solve now because we haven't learned chapter 9 yet, unless you have learned and you come back to see this tutorial, right? But if you are on track at this tutorial, so you haven't covered chapter 9 yet, so we'll just focus on the free body diagram, which is part B, right? So I'll put the diagram over there, the original diagram. And then, so what's the steps to draw the free body diagram is just drawing the outline of the body. So the body, the whole body is something like this, right? It's combination of, is it semicircle? No, it's not semicircle. It's something, there's a function here and then this is a triangle, right? And then, okay, the thing is because the question says it's a plate, etc. So it will have its own weight, right? And this is the thing, the weight and the position of the center of gravity, you have to solve using chapter 9, right? So we don't know, we just draw it as such first because right now we're just focusing on the free body diagram and the support reaction, right? And then what will be the support reaction at point A? It is a pin support. So you can see in the exam, pin support is always there for whatever reason. So, alright, so you'll have AX, AY, right? And then you have a roller at B here, right? So, and B, right? So the thing is this should be perpendicular, right? Because it is, the roller is perpendicular, meaning that it should create a normal reaction there. So it should be 90 degrees there, right? And all the other dimensions, right? So you have 2 meter, etc., right? So, okay, so this is 2 meter, 2 meter, and this is 2 meter, right? And yeah. So that will be the free body diagram. Of course, for our concern right now, you have to understand this, you have to understand this. Obviously, if in the exam this question comes, you have to combine what you understand now with what you understand in chapter 9. Because you have to have all this distance as well, right? And we cannot solve that now because we haven't learned it yet, right? So in terms of the free body diagram, hopefully you understand what to do. In terms of the complete question, we will come back to this question because we're covering the past exam question. This is one of the past exam questions. So when we have covered chapter 9, is it? We will recover this question and solve it until the end. Right now, this is the only thing that we have understood. Drawing the free body diagram. Alright, so going to the next question. Okay, challenges ahead. So why is this slide being put here, right? Now, as what we have covered so far in the 3 questions just now, all of them are 2D, right? So that's all the question that I can find from the past several years of exam question in relation to chapter 5, right? So there's only 3 questions which is 2-dimensional. The rest are 3-dimensional, as we will see after this, right? So the thing is, depending on which semester you are learning, this tutorial can be designed or can be exactly after you have just learned about free body diagram in 2D, where you have learned about support reaction in 2D and then drawing free body diagram in 2D. Okay, the rest of this video and the slide is 3D, right? And in terms of the flow of the lecture and the textbook, you have to learn the support reaction in 2D, equilibrium problem and solution in 2D, and then going to support reaction in 3D and then solving in 3D, right? However, because this tutorial is on free body diagram, so I will continue on and showing the 3D problems and how to draw the free body diagram. So if you haven't covered the 3D lecture yet, at least the beginning where we deal with the support reactions. We will cover after this, maybe it's hard to capture unless you can get the concept, right? So it depends. One option is you go and watch at least half an hour of the lecture video for the 3D, at least on the concept of support reaction, and then come back. That's probably one option. Another option is you just follow and just see whether you understand or not. Hopefully you can capture some things. 3, you can stop here, because when we cover in the tutorial for the 3D, which is 2 tutorial from now, we will see this question back again, and we will draw the free body diagram back again to solve the question in total. However, I will not discuss in detail on the free body diagram then, because it is assumed you already know how to draw the free body diagram. We'll just go and use the free body diagram to solve the question using equilibrium problem, right? So it's up to you. In terms of how this tutorial tally with the lecture, it's until this point, because the rest of the free body diagram will be in 3D, right? So that's just to notify what is going on, right? Because of the nature of the question and the nature of the lecture and the tutorial. All right, moving on. So in this case, you can see this is question number 4, I think. You can see the diagram on the left, and then you have all the questions there, right? So if you can read all the questions if you want, but the part that is related to what we are discussing today is part number 1, which is draw the free body diagram necessary for solving the support reactions at the ball and socket joint A and the supporting cables DB and DC, right? And then you have also the distributed loading, right? So the rest is all the calculations and whatever you have to determine, right? So we'll just focus on drawing the free body diagram, but to do that you have to understand the concept of how support reaction works in 3D, right? But if you actually have understood what is going on for support reaction in 2D, you should be able to pick up the concept. It's the same concept, it's just instead of 2D, it's 3D, right? All right. So first, in terms of free body diagram, you have to draw the body itself. So right now it is the pipe, right? From A to D to the end there. So basically something like, okay, something like that, right? Where you have A here and D here and the rest there. It doesn't have any label there, right? So hopefully you can see the 3D object, right? So that's the challenge as well in the exam, where the drawing should be somewhat able to be understood by the examiner, right? If it's, what is this? So it will be a challenge, right? So I'm focusing on the support reaction. Okay, before the support reaction, of course, we have the distributed loading there. So meaning the distributed loading here should be replaced by one single point force there. And in terms of the value, this is 800 Newton per meter times 3 meter, meaning 2400 Newton, right? Right, so that's from the 800 Newton per meter distributed loading. That's one. And then the rest is basically support reaction. So at A, that is a ball and socket. So hopefully you can imagine by now, from going through the lecture, ball and socket, it restricts the movement in X, Y, and Z, but it allows for every rotation, right? So meaning you will have, so what is the x-axis? X-axis is here, right? So we'll have, for example, AX, AY, AZ, right? So you'll have that 3 support reaction force. It will not have any moment support reaction because it doesn't restrict rotation, right? And then at point D here, you have 2 cables where each cable will have its tension, right? So one is TDB, one is in tension TDC, right? So basically that will be, of course you have to add all the dimensions respective dimension as well for the complete free body diagram. But in terms of the support reaction, you'll have 3 here and 1 cable here, 1 cable there, right? So basically, that's basically all the forces that act on this body over here, right? So yeah, so that's the free body diagram. Not a complete, because add the dimension as well, right? So add the dimension from here to here, for example, because you will need that dimension for calculating moment afterwards, right? So how many unknown you have? 1, 2, 3, 4, 5. All right, so that's the free body diagram for this question. We'll move on to the next question. All right, for this question, we have the diagram on the left there, and then the question on the right. So obviously, I'm not sure whether it's obvious, but it's quite similar to the previous question, the diagram, except for several things, right? One is instead of distributed loading, you have those 2 forces, etc. But the rest is quite similar, meaning that at A you have ball and socket, and then you have 2 cables there, right? So the question says the pipe assembly supports the vertical loads as shown. So the vertical loads, meaning that 3 kN and 4 kN there. Determine the component of reaction at the ball and socket joint A, and then the tension in supporting cables BC and BD. Alright, so for this question, it is similar. So I hope you understand the concept already. So let's try and draw the free body diagram. So again, the first is to draw something like that. Okay, maybe it should be prolonged a bit. So what you have here is 2 forces, something like this, 3 kilonewton, 4 kilonewton, right? And then what you have is basically at A is the ball and socket. So you'll have AX, AY, AZ, and then at point B here, you have the 2 cables again. So you have TBD and TBC, right? And the rest is all the required dimensions, right? So in terms of the forces, there you go. So ball and socket, tension, and then the given forces, right? So it's not difficult actually to get the correct free body diagram for this type of question actually, as long as you understand why this is like this and why this is like this. If you cannot, do make sure to watch the lecture videos in terms of the discussion of how do you determine whether you have support reaction in terms of forces or support reaction in terms of moment, right? And why, etc. The concept is there. Alright, so moving on to the next question. Okay, in this question here on the left, you have the diagram as usual. So you have some rod, some form of a rod there, where the question says determine the X and Y component of reaction at the journal bearing A. So basically at A here, it is a journal bearing, and then the tension in the cords BC and BD, also you have to determine those 2 tensions necessary for equilibrium of the rod shown in the figure, right? So if you see the diagram there, again this is a 3D diagram. You have 2 forces actually given there, and it's given in terms of vector, right? So you have F1 and F2 there, you can see. And yeah, and one thing that you have to understand is the type of bearing that you have. So here you have journal bearing at A, right? So if you have covered the lecture, you should already know that some type of support can be obvious from the drawing itself, while for bearing, in terms of the drawing, journal bearing and thrust bearing is exactly the same. The only difference is in terms of the function, and by the name you can, or you should know the function, right? So the thing is, for journal bearing, if it's like this, it allows for this movement. Right? It allows for this movement. It does not restrict. Right? This movement is allowed. Of course, you cannot rotate. Okay. Of course, you cannot move up and down. Of course, you cannot move in this axis. Right? It's restricted there. Right? But in this movement, it does allow. That is journal bearing. While thrust bearing, it does not allow this one. You cannot move in this direction. right? So that's the difference in terms of the name, right? But the rest, you cannot rotate here, is the same. You cannot move here or upwards, that's the same, right? So that's the thing. So based on that understanding, let's draw the rod here, right? So basically, how to do this? Basically, if this is X, Y, and Z, right? Okay, so basically you'll have something like this, and then it goes for X direction, something like that, right? Something like that, right? So it goes to Y axis and then goes to parallel to X axis. All right. So and then there's two forces here. One force is already given here, which is F2, which is 420J Newton, right? And then here you have something going down. F1 is not going down, minus 850 K Newton. Okay, those two are the original force given by the question, right? So what else? So basically here we go for the easy one first, right? So we have the two cables, so that should be straightforward. So you have one cable here, one cable there, right? So this is TBD and TBC, right? There's two cables there from point B. All right. So the next question is what happened at point A, right? So again, this is a general bearing. So if I ask one by one, right? So in terms of axis, should we have AX? You should have, right? Why? Because it does not allow or it restricts this movement, right? Do you have AY? No, right? Because in general bearing, it does not restrict AY. It does not. Meaning, if this is a thrust bearing, then you have AY because it will restrict that movement. But general bearing, it does allow. It does not restrict, hence there's no force there. And then do you have AZ? Obviously you have, because you cannot move there. Do you have MAX? Yes, you have, because you cannot rotate in that direction, right? Again, in terms of drawing of the moment, you should have both of the thumb and all the finger that rotates, right? The thumb and the finger that rotates. You have to draw both. You cannot occupy this. You cannot make this your thumb and then draw here, because that is redundant, right? Because the moment is drawn with the thumb and the fingers together, right? That's the moment, right? So the thumb and the rotation, right? Do you have MAY? No, because it is free to rotate. Do you have MAZ? Yes. Again, the thumb and the finger, right? So in the end, you'll have 1, 2, 3, 4, 5, 6 unknown in total, right? So that is the free body diagram of that diagram over there. And of course, you have to add the dimensions as well, right? So this is 6 meter, this is 2 meter, right? Okay, hopefully you understand about drawing all the forces there, because make sure you draw it correctly, because if you miss something, your calculation will be missing something, and the mark will be also missing throughout, right? So make sure you understand that, and understand it properly from the beginning, from now. Do not wait and delay until we already do the calculation to start to understand, right? When you want to draw the free body diagram, make sure you fully understand it already, right? Okay, any question, feel free to ask, feel in the comment section, to me, etc., right? Or to your lecturer, etc. Make sure you understand. Next question. Okay, in this question here, we have the signboard basically on the left there, that is hanging from maybe the rod there. So the question says the signboard in the figure has a mass of 80 kg with center of mass at G. Determine X, Y, Z component of reaction at the ball and socket joint A and the tension in wires B, C, and BD. So once again, we made this ball and socket. Now you will notice how many times ball and socket and also cables in the questions, right? And in 2D, you will notice how much pin and also roller, right? There's a reason for this actually, right? Because if you put fixed support, right? For example, in 2D we put fixed support, then the reaction there should be x, y, and moment, right? So that's the maximum already. So if you have fixed support in 3D, you have x, y, z, and then moment x, moment y, moment z. That's already 6 unknown. That's already the maximum as well. So that's the reason why you rarely see fixed support in the exam. You will see, I'm not saying it's impossible, but you rarely see them. You always see the type of support that will enable many different support in one question. For example, here you have cable and then pin support, right? So it enables for multiple support to be tested. And if I put fixed support, there's only one possible support there, right? Anyway, that's just to explain why certain type of support keep coming again and again. Anyway, so to the question, we have basically x, y, z here. So the rod is basically here, right? Something like that, supporting this whole thing here, right? This is in 3D, right? Now, do take the whole thing as the body, right? Do not, I want to detach here. Then you will make your head, you will give headache to yourself how to get the reaction there, right? So just take the whole thing. This is my body here. So that makes it easy. So obviously you will have the weight here already given in the question, which is 80 kilogram. So 80 times 9.81 Newton, right? So that is given. The given one is 80 kilogram. You have to multiply by the gravity to get the Newton. And the rest is just support reaction, right? So at B, straightforward, you have two tension there. One is TBD, one is TBC. And then at point A, you'll have AX, AY, AZ. Of course, pin and socket, ball and socket, you do not have any moment reaction because it allows for rotation, right? Now again, not again, but something that I don't know, I perhaps have forgotten to mention, right? It is suggested that you always draw, for example here, AX, AY, and AZ in the positive direction. You can draw AY to the negative direction as well, right? But later on, when you want to do calculation afterwards, it's easier to follow if everything is positive, positive, positive. So when you want to write the Cartesian vector form of this reaction, it's just AXI plus AYJ plus AZK, right? Otherwise, it's very confusing. AXI minus AYJ plus, meaning it's hard to follow what's going on, right? So it's easier to just assume it to the positive direction, and then if the answer is negative in the end, it simply means it's actually negative. But if you assume negative and then it's negative answer, it's actually positive. So it's very confusing. Avoid any confusion, especially in the exam. Right? Be mindful of the examiner. Right? If you make him mad, he might get mad at your marks. Okay, so that's the thing that you have to consider, right? Alright, so that's the free body diagram. Of course, add on the dimension. You have 2 meters here. Right, so hopefully you understand. Because this one you should already understand by now, is the same tension, is the same ball and socket. However, I think some students, just because they see this signboard, they do not know what to do. So it's actually fairly easy. Just draw the body and draw the forces, and that's it basically. It's not that difficult, right? If you have difficulty in that in the exam, normally it is because you haven't tried. Once you try it, it's becomes straightforward. Oh, okay, it's just like that. Alright, moving on to the next question. In this question, you have the diagram on the left there as usual. Here you have something quite interesting. I think this is the first time we have something like this in the exam, specifically at A, where you have a square rod, right? So basically, okay, you have the rod there from A to B, and then you have the cable, and then you have the force, etc. So the question says, member AB is supported by a cable BC and at A by a square rod which fits loosely through the square hole in the collar fixed to the member as shown. Okay, determine the component of reaction at A and the tension in the cable needed to hold in equilibrium, right? And part B you can read, but we will focus on the free body diagram here. Alright, so before you can even calculate, the first step is drawing free body diagram, of course. Right, so X, Y, Z. So it is something like this, and then it goes down. Right, this is along Y, and then it goes down. Right, and then you have forces here. Oh, the force is, okay, Y is, okay, I have to draw consistently. So if my Y is here, so it is along Y axis. So this seems like, okay, I'll change my Y accordingly to the diagram. Okay, this is 400 Newton along Y axis, and then you get 200 Newton downwards, right? So this is X, Y, and Z. Alright, so the easier thing first, we'll just focus at point B. There's a cable there, so basically you'll have a tension BC there, right? Of course, all of this, it relates back to the earlier chapter, right, where you get Cartesian vector form of this using coordinates, etc., right? So I'm not going to discuss that here because this is about free body diagram, right? But anyway, so this is the tension from the cable. What else is here, right? So at point A, so again, hopefully you understand this. It is basically a collar, right? I hope you understand the collar, right? This collar, right? Not that collar. So meaning a collar at A, it can slide through up and down, right? So we'll go one by one. Okay, will we have AX? Should we have AX like this? We should, right? Because obviously it will prevent this movement. You cannot go and move to the X. We will have AY, yes, of course, because obviously it prevents AY. We will have AZ, no. Why? Because it's free to move up and down, right? Yeah. Do you have MAX? Again, your thumb and the finger, right? Your thumb and finger. Do you have MAX? Yes, obviously, because you cannot rotate about x-axis. Do you have MAY? You will have, right? Because you cannot rotate about y-axis. Will you have MAZ? Yes, of course. Why? Because you cannot rotate about z-axis. Right, this is the difference between a square and a round collar, right? Because if it's a round, then you can actually rotate about z. But when it's square, you cannot rotate. You cannot. You understand that, right? So that's why you have MAZ. Right. So in the end, you have 1, 2, 3, 4, 5, 6 unknown there. Right. So hopefully this is clear. And of course, what is left is the dimension. This one is 3 meter. This one is 1 meter based on the diagram there. Right. So easy, right? So I think the main important thing here is that because some students actually, for whatever reason, they are afraid or they got scared to draw the free body diagram. Make sure you draw. And another thing, if you skip drawing free body diagram, you will lose huge marks because this is one of the learning outcome of this course, statics, right? So you have to show and illustrate you know how to draw, right? So if the diagram is totally missing, you can lose half of marks or 1/3 of the marks of the total question, right? So do not do that. Okay, so hopefully you understand. Moving on to the next question. All right, this question is quite interesting. You can see the diagram there of the one side of the wing of the airplane, right? And I still remember when this question comes in the final exam, at that semester, many students just leave it blank for whatever reason, right? I'm not sure whether they think I'm not an aircraft student, but no, this is just a simple basic question, right? Do not be afraid of question before attempting it, right? So going to the question, so we have the diagram on the left, and then it says the wing of the jet aircraft in the figure is subjected to thrust T equal to 8 kilonewton. So that is you can see the diagram there, T equal to 8 kilonewton from its engine, and the resultant lift force L equal to 54 kilonewton, right? So you have L equal to 54 kilonewton there. So the force is given. Do not be afraid. But I do not know how to calculate thrust and lift force. No. Static is not about that. Those are given, right? Now, if the mass of the wing is 2 megagram, okay, and the mass center is at G, so G is given, but you have to draw on your own 2 megagram there. Determine the X, Y, Z component of reaction where the wing is fixed to the fuselage at A, right? And here is actually a hint already to make it easy to the student. Hint, for the free body diagram of the wing, the type of support of the wing at A is mentioned in the question. So that is some kind of hints already. And what is mentioned, if you read back, it says the wing is fixed to the fuselage. So that's a big hint, right? The hint, the wing is fixed. So it is fixed support, right? All right, so regardless, what to do? So basically, what is the body here, right? The body should be the whole wing, right? So if you have X, Y, and Z there, the whole wing is on the Y axis, right? So we'll have, okay, roughly something like this, right? The wing, and together with what the fuselage, right? What that is, okay, there. Not a problem. We do not judge you on the drawing skill of, at least it's comprehensible, right? Okay, this is the wing, not something like, what kind of fruit is this? Okay, so what is given is you have T here, T equal to 8 kilonewton, and then you have L here, which is 54 kilonewton, and another thing that is given is the weight, right? So you have G here, right? The point G, and then you have okay, this is in terms of the mass, right? 2 megagram, right? 2 megagram. 2 mega is what? 2 times 10 power of 6, right? Gram. Or in terms of kilogram is 2 times or 2000 kilogram, right? And then you have to multiply by 9.81 in terms of Newton, right? So this is 2000 kilogram basically, right? Times the gravity to get the Newton. Alright, so that is the given forces. What about the support action? So here, as the question hinted already, it should be fixed, right? But even if that hint is not given, you should be understand that the wing, how the wing is fixed basically to the body of the aircraft. It will not allow for anything, right? It does not allow this movement or this movement or this movement or what else, or rotation, right? Because the wing is not it's not like that, right? It's just there, right? So yeah, so basically it will be fixed, meaning that you will have AX, where is it, AY, AZ, MAX, MAY, MAZ. You will have all the 6. Can you see that? You have to have all the 6 reaction there, right? 3 reaction force, 3 reaction moment there, because it is restricting or it does not allow for any type of movement or rotation at all, right? Yeah. So there you go. So you have 6 unknown here, and then the rest is known. Add all the dimension there. What, 5 meter, and then 8, and then 15 meter, etc. So you know what to do, right? So that's basically the free body diagram for this problem, right? So it's not difficult actually. Do not be intimidated by a certain type of structure, right? Oh, this is an aircraft, right? I'm not worthy enough to... No, it's just a normal structure, right? Okay, so next question. So you can see the diagram there. There's a curved rod there, and then you have the force. So the curved rod in the figure lies in the XY plane and has a radius of 3 meter. If a force of F equal to 18 Newton acts at its end as shown, determine the support reaction at the fixed end O. So as you can see there, the question already specify that at point O it is fixed, because it says determine the support reaction at the fixed end O. So you have to understand the wording used, right? When we say it is fixed, then it means it is fixed, right? So if you have x-axis, y-axis, and z-axis like that, right? So basically the rod is something like that, right, on the xy plane there, and then basically you have the force there, right, the 80 kilonewton there. In the previous tutorial, I think when we calculate the moment, because I think this diagram is familiar, but because there are another question where I think, because if you see the question here, it is part C and D. There might be part A and B before, where it asks, the question asks for calculate moment of this force about certain points, right? So sometimes the question combined in the sense of A and B from different chapters, C and D in different chapter, right, from the same diagram. Anyway, so so what we are dealing with is a fixed reaction here. So when it is fixed, what do we have? Obviously fixed means you cannot move in any direction, you cannot rotate in any direction, hence you have all the reactions. So you will have AX, AY, AZ, MAX, MAY, MAZ. Now make sure when you draw the moment, the reaction moment, it makes sense, right? Because it is the thumb and the rotation, right? Meaning like this in this rotation, like this in this rotation, right? Like this in this rotation. So it should make sense. You do not draw something that does not make sense. Your thumb is there and then rotation is there. It doesn't make sense. So make sure it makes sense with your right hand rule. Even if you're left-handed, it's still the right hand rule, right? It's not personally. No, I want to look. No, because it's different, right? If you can see here, both are upwards, but this is rotating this way, this is rotating this way, right? It's the different rotation. So you have to use your right hand rule, right? Okay, so basically in terms of the free body diagram, that's what you have: AX, AY, AZ, MAX, MAY, and MAZ. Now another thing that because when I do in the whiteboard, I have my red marker, blue marker, black marker, right? So I can distinguish this and the axis quite easily. But in the exam, if you have only one color, right? So make sure it's quite clear what is what, which is which, right? Which is the axis, which is the force, etc. Otherwise, it can be confusing, right? Otherwise, you have to buy. Do not use red. You have to use, I don't know, other color, blue or red, black or green or something, because red is the examiner, right? Anyway, so that's the question. Moving on to the next question. Oh wait, so there's no other question. So that's it for today. We have covered multiple questions on the free body diagram part. And as you can see here, in the previous exam questions, there are a lot of questions that is going for 3D, that will really test you on 3D. And it will be fun when we do the tutorial for this one, because for each of the 3D question, the solution is quite long, because we have more equation to deal with, and the number of questions is long. So stay motivated for that kind of tutorial. That this 2 tutorial next, we will have quite a long session, I guess, or long recorded session, because there's a lot of question for 3D and each one can become quite long in terms of the solution. We will see that. But anyway, the first step first, make sure every steps you take it step by step and make sure you really understand it. Right? So in terms of the free body diagram, hopefully you really understand it, so that any type of structure given, no problem, establish the free body diagram and then take it from there to solve one by one. We will cover in the next tutorial inshallah in the 2D equilibrium problem, and then after that the 3D equilibrium problem inshallah. Wallahu alam. So I think that's it for today. Thank you for watching. Hopefully you have understood pretty much what you need to understand in terms of drawing the free body diagram. If you have learned anything or it has been beneficial or you get some value of this, feel free to like the video. It will help the video a lot. Thank you. See you next time. Assalamualaikum warahmatullahi wabarakatuh.